Hello guys, welcome to Rebuild Academy. My name is Adil Momin and I welcome you to our series From Virus to Vaccine, Let's Fight Infodemic. I hope you all are doing well, fighting pandemic as well as infodemic. But before we begin, let me tell you a very important point. It is extremely important and highly recommended to watch this series in order. Only then you will get a complete idea and a clear picture of every concept involved. The link is given in the description. Now, let's begin. So far in our study of vaccines, we have covered the history, types, and evolution of immunization. Following that, we discussed many major steps involved in the vaccine manufacturing process. And in the previous video, we explored the many types of vaccines and how they differ. We then discussed the vaccine development and approval procedure, and we tried to recognize the critical distinction between standard and emergency approval. And last but not the least, we noted the different COVID-19 vaccines that are already available with a few more in the development. Right. Today we will discuss several essential concepts such as vaccine efficacy and how it is calculated, as well as breakthrough infection, in which we will try to understand why vaccinated people become infected. Following that, we will discuss vaccine side effects and types, and finally, one of the most sensitive subjects, herd immunity, in which we will discuss the concept of herd immunity and hurdles in the way to achieve it. Okay then, let's begin. Now let's start discussing one of the most debatable topics, vaccine efficacy. Efficacy is the degree to which a vaccine prevents disease and possibly also the transmission under ideal and controlled circumstances. If we look at the efficacy of some of the prominent vaccines today, then Pfizer has 95% efficacy, Moderna has 94%, Covishield 70%, Covaxin 78%, Sputnik V 91%, and Johnson & Johnson 66%. What do these percentages mean and how they are calculated? Let's see with the example of Pfizer. Pfizer performed its phase 3 clinical trial on 43,000 people, out of which half of them, that is 21,500, were given vaccine and the other half were given a placebo. It is important to note that efficacy is determined by comparing a vaccinated group with a placebo group. A placebo is anything that seems to be a real medical treatment but isn't. It could be a pill, a shot, or some other type of fake treatment. What all placebos have in common is that they do not contain any active substance meant to affect the health. Then why do we use a placebo? Because there is something called placebo effect. This is an idea that your brain can convince your body a fake treatment is the real thing, the so-called placebo effect, and thus stimulate healing. It has been around for millennia. Now science has found that under the right circumstances, a placebo can be just as effective as traditional treatment. The placebo effect is more than positive thinking, believing a treatment or procedure will work. It's about creating a strong connection between the brain and the body and how they work together. But that does not mean you can treat yourself just by positive thinking. Placebo won't lower your cholesterol or shrink your tumor. Now, you understand why placebo are used, because we want to offset the effect of placebo in determining the performance of vaccines. Now, coming back to our 43,000 people. When all of these people were exposed to pathogens, then out of them 170 people were found to be infected. Now, we have to calculate the efficacy, for which the formula is as given here. It is the ratio of people who were given a placebo and got infected minus people who were given vaccine and got infected, divided by people who were given a placebo and got infected. Basically, We are trying to find how many people were protected by vaccine by offsetting the placebo effect, and this ratio is multiplied by 100 to represent in percentage form. Now consider the first case. If all the 170 people who were infected are from placebo group, that is, none of the vaccinated people got infected, then putting the values in the above formula will give us efficacy as 100%, which means all the vaccinated people have been protected from infection. Now, consider another case, when infected people are equal from both the groups, that is 85 and 85, then putting the values in the formula will give efficacy as 0%. This implies that vaccine is ineffective because the chances of getting infection are equal in vaccinated and unvaccinated people. But the actual figure from the experiment was 162 from the placebo group and 8 from vaccine group. Using these numbers in the formula will give the efficacy as 95%. This implies that there is a 95% chance that you will not get an infection after being vaccinated. But remember, these trials are under ideal and controlled conditions, and the vaccine performance will vary accordingly in the real world. The vaccine performance in the real world will be evaluated based on vaccine effectiveness, not efficacy. Now you understand what vaccine efficacy means and what this percentage number implies. The question comes, does the vaccine efficacy is important? The answer is yes as well as no. Let me tell you how. If you remember, we are currently discussing the preventive treatment methods in modern medicine. So preventive treatment is to prevent the disease from happening. So the job of a vaccine is to provide protection from disease. Now if you consider this protection absolute in nature, that is, person who is vaccinated should not get an infection in the first place, then vaccine efficacy should be 100%. Then only it satisfies your criteria. Ideally speaking, this should be true, but if we interpret the protection as protection from hospitalization and based on this criteria, estimate the vaccine performance, that is, how many people are protected from hospitalization and getting a severe form of the disease, then you will see all of the above vaccines will give you 95% protection and almost 100%. So, returning to our question, is vaccine efficacy important? The answer is yes, because it is protective treatment. It should have the highest possible efficacy, but it is not absolutely important because it provides more than 90% protection from a severe form of the disease. Let me explain this with one example. The flu vaccine used in the US in 2018 and 19 had an efficacy of just 29%, and only 49% of the population got the vaccine. But the results were astonishing. It was estimated that this vaccine has prevented 4.4 million flu illnesses, 58,000 hospitalizations, and 3,500 deaths. Do you see the results? After this discussion, I don't think anyone will be confused about vaccine efficacy. Now, one of the most interrogative questions is why people get infected even after vaccination. These are called breakthrough infections. Talking about the causes of breakthrough infections, these can be broadly classified into biological causes and other causes. The first factor is age. As people age, their immune system deteriorates. Because of this, even after vaccination, the required amount of immunity is not achieved. Therefore, they are susceptible to infections. Therefore, old people should be vaccinated as a priority group to ensure their safety. In the case of infants, as we know, they have passive immunity naturally acquired from their mother. So, there are chances of interference of these antibodies with the vaccine, thus probably lowering the chances of required immunity. But the chances of interference are mostly in the first 12 to 15 months of the baby. We have learned about adaptive immune response. in which we have discussed the formation of memory B cells, which keeps the history of previous pathogen attacks. Now the life of these memory B cells is variable. Some can be present for decades in blood and some can fade away in months. So if the longevity of memory B cells is small, then it increases the chances of infection. Another important factor is virus mutation. If the virus mutates drastically, like in case of influenza virus, antigenic drift makes the virus novel and there are chances that the immune system will not recognize the new variant, thus causing fresh infection. So these were some of the biological causes of breakthrough infections. Vaccine quality and administration can be one of the causes of breakthrough infection, like vaccine is not stored at a required temperature, which can reduce its effectiveness, or the person has not received the required dose in the prescribed time to keep the immunity level in the protective range. For example, people skipping the second dose are also in the danger of infection, so it is highly recommended to take all the doses in the given time frame to ensure your immunity level is in the protective zone. Now, talking about the number of breakthrough infections, ideally, from the efficacy rate, we can calculate the breakthrough infection rate. For example, if efficacy is 95%, then there are chances of 5% breakthrough infections. But in the real world, there would be more breakthrough infections. Talking about the US, the data till April 2021 indicates that 75 million people were vaccinated, out of which 5,800 people were reported to get infected and out of which 75 people died. Did you notice 75 of 75 million people died? That is 1 in 1 million. The general mortality rate of COVID is around 1.4%. Going by this rate, if all those 75 million had been infected, then there was a chance of around 1 million deaths. If we are talking about India, then according to the results of nationwide study conducted by Indian Council of Medical Research (ICMR) on breakthrough COVID-19 infections, 9.8% of people reported breakthrough infections, and out of which 0.4% have died. So you can see that the protection against severe COVID is almost 100%. Now, after hearing this about breakthrough infections, the next questions will be about the side effects of vaccines. Let's try to explore this. The side effect is a typically undesirable effect of a drug or medical treatment. The side effects of the vaccine can be broadly classified as mild side effects and adverse effects following immunization (AEFI). The adverse event may be any unfavorable or unintended sign, abnormal laboratory finding, symptom or disease. Talking about mild side effects, then these can happen after 1 to 3 days after vaccination. The mild side effects are diverse in nature and any individual can experience different mild side effects. It is also possible some people will not experience any side effects, but the commonly reported side effects are swelling and redness at the injection site, fever, fatigue, muscle pain, joint pain, headache and nausea. These side effects will usually fade away within 2 to 3 days. If you are experiencing them for more than 3 days, it is recommended to contact your doctor. Now the second category of side effects is adverse effects following immunization, that is AEFI. AEFI can be of some certain type. It can be vaccine product related. For example, limb swelling is reported after DTP or tetanus vaccination. Some AEFI can be related to vaccine quality. An example is vaccine-associated paralytic polio, VAPP. It is an adverse event following exposure to oral polio vaccine, which is made with live attenuated polio viruses that can result in a case of VAPP. But VAPP is sporadic and rare. Immunization errors like contamination of vaccines can also cause AEFI. Another reason for AEFI is immunization anxiety. Some people are so afraid of vaccines that they can experience hyperventilation, that is, rapid and deep breathing, which may actually leave them feeling breathless. And some of the events are coincidental. For example, one person got vaccinated and later he got malaria. Now he is experiencing fever due to malaria, but he is thinking of it as a side effect of the vaccine. Therefore, it is recommended that if your symptoms are lasting more than 3 days, then contact your doctor. You might have a different problem. Now AEFI is tracked and monitored by health department of countries through AEFI surveillance, and every couple of months a report is published about how many people reported AEFI and what are the causes of those, whether it was related to vaccine product or quality or it was a coincidental event. In India, the Ministry of Health and Family Welfare Immunization Division do this job. Till July 2021, it has reported a total of 104 cases of AEFI in relation to COVID vaccination. In its recent July report, it has reported 60 AEFI cases, out of which 55 are found to have a consistent causal association to vaccination. Of these 55, 36 were anxiety related, 18 were vaccine product related, and 5 were classified as coincidental events. But it is important to note that out of these 60 cases, only one death is reported. India has vaccinated more than 40 crore people till now with a single dose, and only 104 cases are reported till now, which is very small. Now there is one doubt about vaccines. People are being told that vaccines can cause autism in their children. Autism is a developmental disorder in which the child faces difficulty with social interaction and communication. The cause of autism can be genetic or other. Now let me tell you how this started. There is something called Lancet MMR autism fraud. I am sure you know about Lancet. It is among the world's oldest and best known medical journals. In 1998, Andrew Wakefield, a former British physician, published a research paper claiming the link between MMR vaccine and autism. MMR is measles, mumps, and rubella vaccine. Following the claims in 1998, multiple large epidemiological studies were undertaken. Reviews of the evidence by the Center of Disease Control and Prevention, the American Academy of Pediatrics, the Institute of Medicine of the US National Academy of Sciences, the UK National Health Service, all found no link between the MMR vaccine and autism. Physicians, medical journals, and editors have described Wakefield's action as fraudulent, resulting in the paper's retraction in February 2010 and Wakefield being struck off the UK Medical Register 3 months later. But the damage is caused is irrecoverable. The vaccine coverage of MMR, which was 92% in 1996, dropped to 84% in 2002, causing epidemics and deaths. One more important question that is being frequently asked is when I should take the vaccine after recovering from COVID. Ideally, you should contact your doctor in this regard and follow the guidelines of your country. Since you have recovered from COVID, it means you have antibodies and memory B cells, which can provide you protection for some time. Therefore, it is recommended to wait for 6 to 8 weeks after recovering from COVID till getting the vaccine. But again, your situation might not be general. It is always better to take medical advice from your doctor. Now let's discuss today's last topic, herd immunity. Herd immunity is an indirect immunity which provides indirect protection from infectious diseases. When a sufficient percentage of population has become immune to an infection, whether through vaccination or previous infections, thereby reducing the likelihood of infection. So how this concept came? Herd immunity was recognized as a naturally occurring phenomenon in 1930s when it was observed that after a significant number of children had become immune to measles, the number of new infections temporarily decreased. Now let's see how herd immunity works. The first image shows An outbreak in a community in which a few people are infected, shown in red, and the rest are healthy but unimmunized, shown in blue. The disease spread freely through the population as there is no immunity in the population against it. The second image shows a population where a small number of people have been immunized, shown in yellow. Those people who are not immunized become infected, while those immunized do not. In the third image, a large proportion of the population has been immunized. This prevents the disease from spreading significantly, including to unimmunized people. In the first two examples, most healthy, unimmunized people became infected, whereas in the last example, only a small portion of the healthy, unimmunized people became infected. So, in this way, the healthy, unimmunized people are protected by achieving herd immunity. Mass vaccination to induce herd immunity has become common and proved successful in preventing the spread of many infectious diseases. Now there is something called herd immunity threshold, HIT. It is the percentage of the population that has to be immune in order to achieve herd immunity. For example, measles is a highly contagious disease. It's estimated that 95% of the population must be immune to measles. The remaining 5% will be protected by the fact that measles will not spread among those who are immune. For polio, the threshold is about 80%. HIT depends on disease and its infectiousness. The proportion of the population that must be immunized against COVID-19 to begin inducing herd immunity is not known, but most estimates had placed the threshold at 60 to 70%. But this is not as simple as it seems. The question is, does herd immunity always works? Why I am asking this question? Let me tell you. Let us go to the Manaus city in Brazil. The COVID peaked in April 2020 here, and we saw mass graves stacked with tiers of bodies. But after this, the cases and deaths declined. Hospitalizations also remained low for 7 months, despite relaxed mobility measures. And it was believed that Manaus had achieved herd immunity. In October 2020, a sero survey showed that nearly 76% of the city's 2 million population had already been infected and developed antibodies. Everything was fine, but suddenly in January 2021, the city started to report COVID cases and deaths, and everyone was astonished to watch the deadliest second wave, leaving the healthcare system crippled and hospitals ran out of oxygen. Now you must be asking, how does this happen? A study published in Lancet offered 4 explanations for this. The first one is overestimated herd immunity. However, this doesn't explain everything. Another potential reason was that immunity against the infection could have already begun to wane and gone down by December. The authors noted that studies have shown reinfections could occur beyond 6 months, which is probably what happened in Manaus. However, the authors point out that this explanation is incomplete as well, especially because Manaus went into stricter lockdown with more mobility restrictions from mid-November. The final reason that the researchers offer for the devastating second wave in Manaus is that the newer COVID variants in Brazil, which were highly transmissible and have also been attributed as a likely cause for reinfections or immunity evasion. So what we learned from the above incidents: first, herd immunity is not our goal. Our goal is mass vaccination, which will give us herd immunity as a byproduct. Second, the immunity through vaccination will not last forever. Therefore, periodic vaccination should be implemented to maintain the immunity at protective level. And third, to reduce the effect of variants other than genome sequencing, vaccine rollout should be even at the global level. One of the hurdles in herd immunity is the polarization of vaccines. Rich countries are stockpiling the vaccines, whereas poor countries are waiting for the vaccines. Remember, in this world of globalization, everything is global, even diseases are. The chances of formation of new variants in an unimmunized population are more, and it will not take much time for these variants to spread globally, and it is quite possible one of these variants can neutralize the vaccine-induced immunity. Recent data from Israeli Health Ministry shows the effectiveness of Pfizer BioNTech COVID-19 vaccine has dropped in recent times. The Delta variant is being linked to this. So, a global coalition for vaccination is the need of the time. And another hurdle is vaccine hesitancy. The vaccine hesitancy has evolved primarily due to myths, misbeliefs, doubts, and misinformation. This hesitancy can be countered by listening and answering to the doubts of people. Providing authentic information is also a part of it. So this brings us to the end of today's discussion. Now, as usual, let's quickly revise the topics we discussed today. We started today with vaccine efficacy and tried to understand the concept, after which we talked about one of the most debated topics, breakthrough infections, and tried to decode it. We also discussed different side effects of vaccines, AEFI, and its surveillance. We also gone through the origin of the connection between autism and vaccines, and lastly we discussed herd immunity and some details regarding it. Right. In the upcoming video, we will be discussing symptomatic treatment of COVID. In addition to this, some of the crucial concepts like monoclonal antibodies and plasma therapy will be discussed. So make sure you subscribe the channel and press the bell icon for timely notifications. If you enjoyed and learned something from this video, then ensure that you like the video and share it with others so that we all work together and battle the infodemic. If you have any suggestion for me, then you can comment below. That's all for now. We will meet in the next video. Stay safe, stay connected.